Hello, it's Dumplet here. Here's an item on algebra, specifically on inequalities. X, y, and z are positive real numbers such that xy plus yz plus zx equals 3xyz. We're asked to prove that x squared y plus y squared z plus z squared x is greater than or equal to 2 times x plus y plus z minus 3. Credits to the Balkan Math Olympiad back in 2014 for this item. I believe this item was a problem 1. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, we're given with a very bizarre condition that xy plus yz plus zx equals 3xyz. And we might be able to simplify this a little bit. It's one of the common techniques in Math Olympiads. Maybe you want to see what happens if we divide both sides by x, y, z. So xy over xyz, that just becomes 1 over z. Yz over xyz becomes 1 over x. Zx over xyz becomes 1 over y. So 1 over z plus 1 over x plus 1 over y equals 3. Or I can just say that it's just going to be 1 over x plus 1 over y plus 1 over z. That's going to equal 3, just to be more symmetric. Now, let's change the negative 3 here to negative 1 over x minus 1 over x minus 1 over y minus 1 over z, since we have this equality from the given. So we can use that. And then let's just put these on to the other side so that there will be, all the signs here is going to be positive. So we're just technically adding some positive terms, and then it's going to equal to some sum of positive terms on the right side. Now, this is because when talking about inequalities, there are more theorems that there are more things we can do with positive signs, because there's a lot more theorems based on like addition of terms instead of like subtraction of terms. So that is the reason why, and we can try to make some observation here, because all right, x squared y and the 1 over y might go well together, and with the same observation, the z squared x and 1 over x, same for the y squared z and the 1 over z. Now, why is that so? Because of the AMGM inequality. Again, what does the AMGM tell us? It just tells us the arithmetic mean of some numbers is greater than or equal to the geometric mean of some numbers. So we're going to have it here. All right, I'm going to do the same highlighting that I did. So it's going to be this and this, this and this, and then this and that. And take a look. For the underlined yellow term, it's going to be this one and this one. And okay, the arithmetic mean is divided by 2, but let's just multiply by 2 both sides. So by the AMGM inequality, this will be true. So twice their geometric mean. Same for the green underlined terms. Then obviously for the red underlined terms. So these are all true. But what's more interesting is that what this equals to, because 2 square root of x squared y times 1 over y, that's just actually equal to 2 square root of x squared. And we don't really need to worry about signs here because x, y, and z are positive, as mentioned at the start. So we know that this is just simply equal to 2x. And by the same logic, this will equal 2y, and this would equal 2z. And therefore, we're actually almost done with the proving this inequality, just because, well, I think what we can do is just add these 3. Now, if I add these 3, I would get the yellow terms, the green terms, the red terms, as you can see on the left-hand side. And then on the right side, I'll be getting 2x plus 2y plus 2z. And I can easily just factor the 2 out to get x plus y plus z here, which is identical to the right-hand side of the this inequality. Now, since this is true, this red boxed inequality is true, therefore this original inequality will be true, since that red box inequality just came from the original this inequality. It's just the same as this red box inequality. Now, as per normal Olympiad fashion, we have to check for the equality case. So we might want to see whether or not the equality will hold. And all right, according to the AMGM inequality, when will the equality hold? Well, very simple. For the AMGM inequality, the equality will hold if the terms the terms that we are working with, they're the same. So, for example, equality will hold for the first equation if this and this one are the same value. You can try to verify this on your own, but that's going to be what the equality case of the AMGM inequality is. So same for this one, the y squared z is going to equal to 1 over z, and then the z squared x is going to equal to 1 over x. So let's just try to deal with the first one first. So x squared y equals 1 over y. So multiply both sides by y, we're going to get that x squared y squared equals 1. Again, we don't really need to worry about signs because x and y are positive. So here it's going to say that xy equals 1. And by the same logic, in the second one, we will be able to get that yz is equal to 1. And in the third part, we're going to get that zx equals 1. And all right, we can do the trick where we multiply everything and then take the square root. So if I multiply everything, I would get x squared y squared z squared equals 1. But since they're all positive anyways, I would know that xyz is just simply equal to 1. And since xyz equals 1, it's going to follow that x equals y equals z, and they're all equal to 1 for the equality to hold. All right, so since the equality will hold, then therefore we can conclude that the given inequality is true, and with equality case, so with the equality at x equals y equals z equals 1. And that's going to be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!